Hello, this is Gemma Hernandez-Milian. I'm working on top predators and the incidence of microplastics in their digestive tracts and the traffic transfer of these pollutants. In particular, I'm working on marine mammals in European waters. Today, I'm bringing some results from the Plastic BUSTERS MPA project. I'm not going to go deep into this project as other colleagues have been explaining it. I just want to emphasize that the project is trying to address the management cycle of the marine litter, where monitoring and assessment at marine protected areas are important. In this case, we're trying to understand the impacts on biota, and we are using an endangered top predatory species as a proxy, which is the Mediterranean monk seal. This is the most endangered marine mammal in Europe and is exposed to several threats. One of them is related to this topic, which is the pollution. Just to get in context, this is the area distribution of this species in the past along the whole Mediterranean, the Atlantic Ocean and the Black Sea. However, nowadays, we only have 3 subpopulations. One is concentrated in Cabo Blanco Peninsula in Mauritania with 360 seals, another one in Madeira Island with 20 seals, and the largest one is concentrated in the northeastern Mediterranean with 700 seals, where only 450 seals are considered mature. Getting into our area of sampling, this is Greece, and we sample in Zakynthos Island. And this reason is because we have a protected area and is regularly used by seals, by Mediterranean monk seals in this island, the caves of this island. And we are able to get access to these caves always through sea because they don't have land access. We collect the samples and we bring them into the lab where we weigh them. As you can see, they're large samples, so we cannot process them under a hood. We had to use the sink. So in this case, we need to be sure that we have more or less controlled the airborne contamination. We put blanks along the whole area, and we put a filter in the tap, as you can see in the photo, and we put a set of nested sieves where the 2 tops are the ones that we collect the items and the micro debris, and the one on the bottom, which it has less than 300 microns, is where we collect the sample for micro debris analysis. This part of the sample is put in a solution of 10% KOH for 3 weeks. However, due to the type of sample that we have, not always we get a digestion of all the particles that you can see in the photo. Therefore, we need to do a density separation. So we did it with sodium chloride and sodium iodine, and then we filter it. And then we did the visual identification and measuring, plus the polymer identification with FTIR. In total, we collect 12 scats from 4 caves, and a total of 160 particles were found. As in previous studies, 84% of the particles were filaments, but it's important to notice that we find out a piece of net, which was larger than 3 centimeters. An average of particles per feces were about 14, and 70% of the particles were smaller than 3 millimeters. 39% of the fibers were blue and 34 were transparent as the main fibers or particles found in the sample. In terms of polymer identification, we have an issue with the size of the polymers, the particles, because they were too small. 62% of them were not possible to identify correctly. So within the 38 that we got identified, 27% were polyamide. In conclusions, just to say that marine litter can be detected in feces of seals, so we can use a non-invasive technique for micro debris incidence and even in trophic transfer. We're right now working on identification of prey species to understand if there is a trophic transfer depending on which kind of prey they are eating, but this haven't done yet. But now we can see that feces can be something to use as a monitoring system and an assessment of this particular pollutant. In terms of particles, we find out about 14 particles per feces. It is important to say that previous work that they were using the whole digestive tract, they found out 20 to 30 particles per animal. So with a really huge variation, of course. So we need to be really careful when we are using only the feces. It's true that it's an important tool because we don't need, in particular with endangered species, to collect carcasses, which are hard to get. But also we need to be careful with that particular bias that we might be losing some information due to that we don't have the whole digestive tract and some of the particles get stuck over there. Also, in addition, we have followed the protocol having been published before and has been tested successfully. And as the main bias that we have, also considered with the third point that I'm putting in the conclusions, we need to have an airborne control, an airborne pollution control, both at field and in the lab. As I said, we have an average of 14 particles per feces, but we cannot be 100% sure that they are coming from the cave. We reject those particles that they were likely to come from the soutes that our technical people were collecting the samples, so neoprene ones, but we don't know if there were currents in the caves that they were they had some fibers that they can get into the samples. We assume that they were not, and also in the lab we try to control our conditions as much as we can. I just only want to acknowledge Plastic Buster project, specifically Cristina Fossi, who encouraged us to carry out this research. Also, all the colleagues in Hellenic Centre, and a special thanks to the National Park people who allow us to do this research. Thank you very much, and I will answer any question.